liter of 0.2 m H2SO4 is reacted with 2 liter of 0.1 m NaOH solution. The molarity of the resulting product Na2SO4 in the solution is dash millimolar. Now the reaction is H2SO4, 1 mole of H2SO4 plus 2 moles of NaOH forming Na2SO4 plus 2 moles of H2O. Now molarity into volume will give number of moles. So moles of H2SO4 will be equal to molarity of H2SO4, that is 0.2, into volume of H2SO4, that is 2 liter. So this is equal to 0.4 moles. So initially 0.4 moles of H2SO4 is present. Then moles of NaOH will be equal to molarity of NaOH, that is 0.1, multiplied by volume of NaOH, that is 2 liter. So number of moles of NaOH is 0.2 moles. So moles of NaOH present is 0.2 moles. Now to find the amount of Na2SO4 formed, first of all identify the limiting reagent. Now to identify the limiting reagent, divide the number of moles by stoichiometric coefficient. So number of moles of H2SO4 is 0.4 divided by its stoichiometric coefficient 1, and this is equal to 0.4. And the number of moles of NaOH, that is 0.2 divided by its stoichiometric coefficient, that is 2, is equal to 0.1. Now on dividing the number of moles by stoichiometric coefficient, the value for NaOH is less than the value for H2SO4. So NaOH is the limiting reagent. So amount of Na2SO4 formed depends upon the amount of NaOH present. Now number of moles of NaOH divided by its stoichiometric coefficient will be equal to number of moles of Na2SO4 formed divided by its stoichiometric coefficient, that is 1. So number of moles of Na2SO4 formed is, this is 2 under 2 and this is 2 into 0.1 is 0.2. So number of moles of Na2SO4 formed is 0.1 mole. Now total volume of the solution on mixing 2 liter of H2SO4 and 2 liter of NaOH, the total volume of solution will be equal to 2 plus 2, which is equal to 4 liter. So the molarity of the resulting Na2SO4 solution will be equal to moles of Na2SO4, that is 0.1 divided by 4, and this is equal to 0.025 m. And if we want the answer in millimolar solution, then just multiply it by 1000, and this is equal to 25 millimolar solution. So answer here will be 25. A 1.84 milligram sample of polyhydric alcoholic compound X of molar mass 92 gram per mole gave 1.344 milliliter of hydrogen gas at STP. The number of alcoholic hydrogens present in compound X is. Now suppose 1 mole of the compound contains Z moles of alcoholic group, and each alcoholic group contains 1 hydrogen atom. So Z moles of alcoholic group will contain Z moles of hydrogen atom. Now moles of hydrogen is equal to volume of hydrogen in liters divided by molar volume, and this is equal to 6 into 10 to the power minus 5 moles. Now 1 mole of hydrogen contains 2 moles of hydrogen atom. Therefore 6 into 10 to the power minus 5 moles of hydrogen molecule will contain 2 into 6 into 10 to the power minus 5, that is 12 into 10 to the power minus 5 hydrogen atoms. Now moles of organic compound. Moles of organic compound will be equal to weight of the organic compound. This will be 10 to the power minus 3. So weight of the organic compound in grams divided by molecular weight of the organic compound given in the question, that is 92 gram per mole. Solving, number of moles of the organic compound is 2 into 10 to the power minus 5 moles. Now 1 mole of organic compound contains Z moles of OH group. Therefore 2 into 10 to the power minus 5 moles of the organic compound will contain 2 into 10 to the power minus 5 into Z moles of OH group, and this is also equal to moles of hydrogen atom. So it can be written that 2 into 10 to the power minus 5 into Z is also equal to moles of hydrogen atom, and moles of hydrogen atom is 12 into 10 to the power minus 5. Solving, the value of Z will be 12 into 10 to the power minus 5 divided by 2 into 10 to the power minus 5, which is equal to 6. Therefore, there are 6 alcoholic hydrogens present in the given organic compound. Volume occupied by 4.75 gram of acetylene gas at 50 degree centigrade and 740 millimeter mercury pressure. So volume is equal to nRT divided by P. N is the number of moles. तो N की वैल्यू क्या हो जाएगी? Weight, that is 4.75 divided by molecular weight of acetylene. Molecular weight of acetylene है 26. R की वैल्यू है 0.0821 लीटर एटमॉस्फेयर पर केल्विन पर मोल. टेम्परेचर केल्विन में हो जाएगा 323 केल्विन. 273 plus 50, this is equal to 323 Kelvin. Now pressure in atmospheres will be, pressure given है millimeters of mercury में, तो pressure in atmosphere हो जाएगा 740 divided by 760. So putting the values and solving, volume आ जाएगा 4.97 liter, which is approximately 5 liter. तो यहाँ पे आंसर हो जाएगा 5 liter. 1.86 gram of aniline completely reacts to form acetanilide. 10% of the product is lost during purification. Amount of acetanilide obtained after purification in gram is 10% lost. मतलब amount of acetanilide obtained is 90%. That is, out of 100 gram, 90 gram of acetanilide is formed. If the amount of aniline is 100 gram, then 90 gram of acetanilide is formed. Now aniline molecular weight is 93. Acetanilide molecular weight is 135. Now according to this reaction, 93 gram of aniline gives 135 gram of acetanilide. So 1.86 gram of aniline will give 2.7 gram of acetanilide. Now 10% of it is lost. Only 90% is obtained after purification. If initially 100 gram of acetanilide is formed, then 90 gram of acetanilide is obtained after purification. Therefore, if initially 2.7 gram of acetanilide is formed, then after purification 2.7 into 90 divided by 100, that is 2.43 gram of acetanilide is obtained. 2.7 into 90 divided by 100, that is 2.43 gram of acetanilide is obtained, and this can also be written as 243 into 10 to the power minus 2 gram. So here the answer is 243. The reaction of sulfur in alkaline medium is given below. Reaction given है and we need to balance this reaction. ये redox reaction है जिसमें S8 oxidize भी हो रहा है और reduce भी हो रहा है. तो this is a kind of disproportionation reaction. तो इसको balance करने के लिए first of all reactant side में we will write S8 plus S8 forming S2 minus plus S2O3 2 minus. Now one of the S8 is getting reduced and another one is getting oxidized. S2 minus में oxidation state है सल्फर का -2 और यहाँ S8 में है 0. So reduction is taking place from 0 to -2. S2O3 2 minus में सल्फर का ऑक्सीडेशन स्टेट होगा सपोज X. सो टोटल ऑक्सीडेशन स्टेट यहाँ पे 2 एटम्स ऑफ सल्फर है तो टोटल ऑक्सीडेशन स्टेट हो जाएगा 2x minus each oxygen has oxidation number of -2. So there are 3 oxygen atoms. So 3 into -2 is -6. So 2x minus 6 is equal to -2. So 2x is equal to +4 X is equal to +2. Each sulfur atom has oxidation state of +2. So 2 sulfur atoms will be having oxidation state of +4. तो यहाँ पे 2 सल्फर एटम्स हैं, तो 2 सल्फर एटम्स का ऑक्सीडेशन स्टेट हो गया +4. तो यहाँ S8 में 0 है और S2O32 माइनस में टोटल ऑक्सीडेशन नंबर है +4. तो यहाँ पे ऑक्सीडाइज हो रहा है. नाउ नंबर ऑफ सल्फर एटम्स को पहले बैलेंस कर लेते हैं. S8 चेंजिंग टू S2 माइनस, तो यहाँ पे 8 एंड S8 चेंजिंग टू S2O32 माइनस, तो यहाँ पे हो जाएगा 4. सल्फर एटम बैलेंस हो गया. अब टोटल चेंज इन ऑक्सीडेशन नंबर, S8 चेंजिंग टू S2 माइनस, टोटल चेंज हो जाएगा, पर एटम चेंज है -2, तो टोटल चेंज हो जाएगा 8 इंटू -2 विच इज इक्वल टू -16. और यहाँ पे 2 एटम्स ऑफ सल्फर में टोटल चेंज इन ऑक्सीडेशन नंबर है +4. तो यहाँ पे 4 इंटू S2O3 जब करेंगे तो 4 इंटू 2 टोटल एटम्स ऑफ सल्फर हो जाएगा 8. 2 atoms of sulfur change in oxidation number is +4. So total 8 atoms of sulfur change in oxidation number will be +16. Or in short we can also write, यहाँ पे 8 है तो 8 into -2 is 16 और यहाँ पे 4 है तो 4 into +4 is also 16. Now the total change in oxidation number in both the cases is same, that is 16. Next we have to balance the negative charge. 8 into S2 minus, यहाँ पे total charge हो गया -16 और यहाँ पे 4 into 2 minus is -8. So total negative charge on the right hand side is -16 -8 which is equal to -24. On the left hand side we need to add 24 OH minus ions so that the total negative charge on the right hand side is same as the total negative charge on the left hand side. See here 8 into -2, total negative charge -16, 4 into -2, negative charge -8, total -24. On the left hand side also we will add 24 OH minus ions so that the total negative charge becomes -24. Now negative charge is also balanced. Now next balance the number of oxygen atoms. Now number of oxygen atoms on the right hand side is 4 into 3, that is 12, and on left hand side is 24. So we need to add 12 more oxygen atoms on the right hand side. For that we will add 12 H2O on the right hand side. तो नंबर ऑफ ऑक्सीजन एटम्स भी बैलेंस हो गया. नाउ नंबर ऑफ हाइड्रोजन एटम्स, राइट हैंड साइड में टोटल हाइड्रोजन एटम्स हो गए 12 इंटू 2 दैट इज 24. लेफ्ट हैंड साइड में भी 24 हाइड्रोजन एटम्स हैं. नाउ दिस रिएक्शन इज बैलेंस्ड. अब बैलेंस्ड रिएक्शन को लिख लेंगे. S8 प्लस S8 ये हो गया 2S8 प्लस 24 OH माइनस फॉर्मिंग 8S2 माइनस प्लस 4S2O3 2 माइनस प्लस 12 H2O. अब इस पूरी इक्वेशन को 2 से डिवाइड कर देंगे तो ये हो जाएगा S8 प्लस 12 OH माइनस फॉर्मिंग 4S2 माइनस प्लस 2S2O3 2 माइनस प्लस 6H2O. तो ये हो गई बैलेंस्ड इक्वेशन. सो वैल्यू ऑफ A, that is number of OH minus ions or number of moles of OH minus ions on the reactant side is 12. In basic medium, CrO4 2 minus oxidizes S2O3 2 minus to form SO4 2 minus and itself changes into CrOH whole 4 minus. The volume of 0.154 m CrO4 2 minus required to react with 40 milliliter of 0.25 m S2O3 2 minus is dash milliliter. तो जो रिडॉक्स रिएक्शन है वो है CrO4 2 minus plus S2O3 2 minus forming CrOH whole 4 minus plus SO4 2 minus. तो यहाँ पे क्रोमियम का ऑक्सीडेशन स्टेट चेंज हो रहा है फ्रॉम +6 to +3, so it is getting reduced. So change in oxidation state per atom of chromium or change in oxidation number per atom of chromium is 3 and sulfur का oxidation state change हो रहा है from +2 to +6. So change in oxidation state or oxidation number for one atom of sulfur is 4 and in S2O3 there are 2 atoms of sulfur. So total change in oxidation number is 2 into 4, that is 8. Now molarity of CrO4 2 minus, that is 0.154, into volume of CrO4 2 minus in milliliter, let it be V, into valency factor. Now here valency factor is the change in oxidation number of chromium, so it is 3, is equal to molarity of S2O3 2 minus, that is 0.25, into volume of S2O3 2 minus, which is 40, and valency factor is total change in oxidation number of sulfur, total change in oxidation number of 2 atoms of sulfur or 2 moles of sulfur. So this is 8. So this is the valency factor. So M1V1 into valency factor is equal to M2V2 into valency factor. Solving, volume is equal to 173 milliliter. So here the answer will be 173.